Okay, we're fixing it. This video is going to be about how I'm going to use the dot product. Hopefully I'll get through all this in one video, but if not, we'll just continue it. One way I'm going to use the dot product is in certain cases I can use it to find the magnitude, so we're going to look at that in this video. The second use is to find the angles between two vectors. I don't know what happened there. I quit writing apparently. So if I have two vectors, how do I know the angle that's between them? We can use the dot product. All these are different formulas we're going to learn that we'll be able to use. And then we already mentioned this use of it. We can tell if two vectors are orthogonal if we do the dot product and we get 0. So we already know that third case there. And another way is another use of it is to find the projection, and I didn't have enough room to finish the sentence, to find the projection of a vector onto another vector. So we'll be talking about what that means and how we do it. Let's go to the first use of it, finding the magnitude in certain instances. All right, you're going to get some problems that will read this way. The dot product of a vector, u, we'll call it u, with itself, so you're going to do the dot product with itself, with the same vector, two vectors, is 5. What's the magnitude of u? So, to clarify, I think I misspoke a minute ago. If I have a vector and its dot product is 5, that means u dot u is 5. So that means u1, u2 dot u1, u2 is equal to 5. Okay, that's what that's saying. Okay, now we can write it. We have a property that I mentioned in the last video, and it's that if we have the magnitude of u squared, it is actually equal to the dot product of the vector with itself. So, what is the dot product of u with itself? Well, they told me that up here, didn't they? They said it was 5, so this part is 5. So the magnitude of u squared is 5. If I want to know what the magnitude of u is, I can just square root both sides. Remember, we're talking about the dot product is just a number here, so the magnitude of u then, it follows that the magnitude of u, if you square root the magnitude squared, you just get the magnitude, is the square root of 5. So that's one place where we can use the dot product. Another use of the dot product is to find the angle between two vectors. So you have a formula. I should write that over here. Angle between two vectors, since I didn't write it at the top. Okay, so we got vectors maybe going like this. Maybe u goes this way and v goes this way, and we want to know what's this angle here. Remember, we always measure angles counterclockwise, even if we're not really on the grid at the moment or something. So, okay, so the formula, which I started writing before I wrote the title, is the cosine of the angle between them is the dot product of the two vectors divided by each of the magnitude of the two vectors. Okay, so let's do a problem like that. One thing to note, the angle is whatever this angle is, theta, that we're going to find, it has to be between 0 and 180. We're always measuring the shortest angle between the two, we're not going to measure all the way. Like, for instance, we're measuring that way. What we are not measuring is this. We're not going to find that angle. If I want to know what that angle is for some reason, I can always subtract that angle from 360 and get it, but I'm not interested in I'm interested in the shortest angle between the two. Okay, so you could have said 0 is less than equal to pi too. I could have said pi instead of that. Normally what we do is we look at these from their standard vector positions too, so that also helps it make a little bit more sense about why we would limit it to between 0 and 180. All right. So if I've got vector u and it is 4, 3. And I've got vector v, and it is 3, 5. First of all, I need to know their magnitude, because I see there's parts I need here, right? I need the magnitude of each one. Here's the magnitude of u. Here's the magnitude of v. I'm going to have to find that. And in order to use this formula, I'm also going to have to find the dot product of the two. Let's find the dot product first, since they're sitting so close to each other. That makes it kind of easy. So I'm going to do that in red, since I circled the dot product in red. U dot v would be, remember how we do it? You multiply the two x parts together, so it's 4 times 3. And then you multiply the two y parts together, 3 times 5. And you add them together, so that's going to be 12 plus 15 is going to be 27. Okay? So on the top, we can put 27 up here. Now I'm going to find the other parts, and I'm going to write them in the color that I used to circle them, just so you can kind of follow the color pattern if you need to. All right, the magnitude of u. The magnitude is just the square root of the two parts of the vector squared. Okay, so I have 4. I'm going to square it, and then I'm going to add in 3 squared. Okay, like the distance formula. So that's the square root of 16 plus 9, which is 25. So I'm looking at the square root of 25, which is 5. So for this green part down here, I'm going to put in 5. And now I need to multiply it by the magnitude of v. And I'm running short on room here, but hopefully you can read this. If not, listen to what I'm saying and try to make sense of it. All right, and I need to square root the two parts squared and added together. So I have a 3 here. I'm going to square 3. It's 3 squared plus, I have a 5, so 5 squared. So that's going to be the square root of 9 plus 25. 9 plus 25 is 34, so it's the square root of 34. All right, so that's going to be the square root of 34 up here. So let me see if I can write it a little bit. Let me go to the next page. Notice what you should have written down. Remember, you can pause the video if I'm progressing too fast, or you can always rewind it. What I have now is the cosine of theta is equal to, the dot product was 27, and on the bottom I had the magnitude of u was 5, and the magnitude of v was the square root of 34. Now, if I were to put this fraction in my calculator, I would end up with the cosine of theta. I'd have to do the inverse cosine, wouldn't I? Because I'm trying to find the angle. I've got the cosine fraction. I need to find the angle. So I'm in my calculator to calculate this, because this is not going to be something we're going to know from the unit circle. I'm going to be typing in, second cosine for this cosine, arc cosine. Remember, we could also write that as arc cosine of, I'm going to type, let me do it up here, just because I'm going to confuse myself if I start trying to jump back and forth. Cosine inverse and the inverse, and then the calculator opens the window. Remember, what I'm going to type in is that 27 divided by 5 square root, which is second square, x squared, and 34. And when I do that in my calculator, if I've got it set on degrees, we get 22.2 degrees. So that would be the angle between those two. There's something that follows from this also. I'll do that on a separate page. So anyway, that's how we find the angle. There's a formula that sometimes people call the alternate form of the dot product. If you noticed, we had this equation that we just got through using, and we just filled in the parts of it that we needed. It was u dot v over a magnitude of u times the magnitude of v. Now I could put cosine theta over 1, and I could cross multiply, and if I did that, I would get u dot v times 1, which would be u dot v. If I cross multiply the other, if I do this part of the cross multiplying, I get the magnitude of u times the magnitude of v, and then cosine theta. So sometimes people call this the alternate form of the dot product, because if you know the magnitudes and the angle between them, you can just find the dot product that way if you need to use it for something else. Okay, well, I'm running out of time, and actually, I can get this in. Orthogonal vectors we already did, so just refer to it earlier on. And remember that for orthogonal vectors, if you do the dot product and it's 0, that means the two vectors are orthogonal or perpendicular. It means the same thing. They're at right angles to each other. Okay, so let's try. I think I can make one up. So 3, -5, and if I put 5, -3, that's not going to work. -5, +3. Let's try this one. Okay, let's try this. Let's let this be U and this be V. If I wanted them to see if these are perpendicular, when I do their dot product, I should get 0. Let's see if it happens. Okay, so remember we multiply the two x parts. So it's 3 times -5. We know that's -15, so I'm just going to go ahead and write it. And then we multiply the two y parts. -5 times 3. We're going to add them together. -5 times 3. That would be another -15. So that would be -30. Those are not orthogonal. How could I make them orthogonal? Let's see if we can figure this out. If I needed a +15 right down here when I multiplied the y parts, so it looks to me like what I should have done if I wanted to make them orthogonal. Let me do that on the next. See if I can get another slide pulled up. So let's try this. 3, 5, -5, 3. Okay, so now let's try it. 3 times -5, let's the dot product. 3 times -5 plus 5 times 3 would be -15 plus 15 is equal to 0. So if you have all of them the same sign and just one term with an opposite sign, okay, if you look at what the pattern is, here's a 3 and a 5. So I need, if I have a 3 and a 5 here, I want the opposite term to be here and here. If I were trying to make up my own orthogonal vector, I'd want 3 of them to be the same sign and one of them to have a different sign. I could have also had an orthogonal one if I did this, because 3 of them are the same sign. Whoa. Yeah, that would be right. Sorry. 3 of them are the same sign and one of them's different. So that would also have a dot product of 0. So that would be orthogonal too. So those are going to be our main uses of the dot product. We all have another video for us in this section, but it's going to have a slightly different focus.